Good afternoon, ladies and gentlemen, and welcome to the third open session of the 20th World Knowledge Forum. I am Byung-Hoon Chung, co-CEO of D-Street, which is one of the leading blockchain news media and community in Korea, and also co-founder of Blockcrafters, the biggest blockchain accelerator based in Korea. Prior to joining the blockchain industry, I founded 2 different companies and sold my second company to a unicorn in 2015. I've got to know about blockchain in 2017 while I was doing some company building and decided to do my own startup for the 3rd time. D-Street is a joint venture between Mail Economy, the biggest financial newspaper in Korea, and the host of World Knowledge Forum. Blockcrafters, biggest blockchain accelerator, and Daily Financial Group, biggest fintech company in Korea with the ICOM project and Coin1 Exchange. As a media, we report current news on crypto industry and send out a weekly newsletter to our Korean audience. If you're interested in learning about about the blockchain and trends of the Korean market, there's supposed to be a QR code of the newsletter, but I'm sure, yeah, that's the QR code, so feel free to subscribe to our newsletter. As we're in an emerging industry, we would like to encourage more talents to come in to this industry, and that is why we have Mr. Vitalik Buterin speaking with us here today. In the blockchain world, Vitalik is a man who doesn't need an introduction. He was involved in the Bitcoin community since 2011 by co-founding and writing articles for the Bitcoin magazine. In 2013, Vitalik published the white paper for the Ethereum, which is the now world's 2nd most valued cryptocurrency in the world. Today, Vitalik is going to give us a presentation on building digital institutions based on blockchain. After this presentation, I will ask a few questions, followed by questions from the audience. So please visit slido.com and ask questions that you want to ask Vitalik today. I think this is a topic that is very suitable for the open session, as a lot of people here today probably heard about blockchain and perhaps also invested in Bitcoin, Ethereum, or other cryptocurrencies, but doesn't know really about what blockchain technology is and its implication it has on our everyday lives. So without further ado, Mr. Vitalik Buterin.
Okay, so hello everyone. How is everyone doing today? Yay, everyone's doing great as usual. Excellent. So who here has heard of blockchains before? Okay, so some people, but not everyone. So I guess, to start, if you have heard of blockchains, then there's some kinds of blockchain applications that you may have already heard of, right? So the most popular one and kind of the original one, obviously, is cryptocurrency itself, right? So Bitcoin, it's the very first cryptocurrency. It allows you to make payments very easily to anyone, basically anywhere in the world, and it's a open public network that has been running for over 10 years. Now, Bitcoin is, of course, not the only cryptocurrency. In the Ethereum platform, there is Ether, which is also a cryptocurrency, and Ether, as Byung-Hoon mentioned, is the kind of 2nd largest one after Bitcoin, and there's many others as well. Right? So cryptocurrency is the application that the blockchain space kind of started with, and there's plenty of people using it to do a lot of really valuable things, right? So international payments, for example, even my own organization, the Ethereum Foundation, uses cryptocurrency to do payments to contractors in many cases because it's by far the easiest way of doing that. And I know there's many people in many different countries, whether it's Asia or Africa or other South America and other places, that use it every day to basically work for software companies that are based in other places and be able to get the money back home without going through large hassles and paying big remittance fees. So it is something that people are using. It's benefiting people's lives, but it's not the only application. So ENS, the Ethereum name service, is probably the most widely used kind of non-financial example of blockchain technology. And what ENS does is it's basically a replacement for centralized domain name systems. Right, so when you go to a website right now, like in order to figure out like which server you have to talk to go to a particular website, there exists this kind of set of centralized servers that basically act as a phone book, kind of telling your computer where to go. So ENS tries to take this piece of core internet infrastructure and replace it with a decentralized alternative with no single points of failure. Cryptocurrency and blockchain technologies are starting to be used for kind of disaster relief, refugee payments, and similar kinds of applications. Another example of non-financial blockchain applications is using blockchains as a place to store records about like university degrees and potentially other kinds of certificates. And basically, users can check the blockchain to verify that some certificate is still valid. So this basically kind of fights fraud of theoretically any kind of attestation, any kind of formal thing that some person or organization might say about someone else. So these are like some blockchain applications that are kind of out there, but I wanted to kind of zoom in today on a particular class of blockchain applications that people have been starting to do a lot of kind of research and thinking and even development and use of. So let's start off by talking about DAOs, right? So DAOs are this kind of grand vision that has existed for over 5 years now. It stands for Decentralized Autonomous Organization, and the idea here is you have what's called a smart contract, a computer program that's automatically executed on the blockchain that directly controls digital assets, and these digital assets could be money, or they could be a domain name, they could be any other kind of asset, as long as they can be represented on a blockchain. And the smart contract directly controls, has the ability to spend these assets, and the code, the logic of this program represents the rules by which some group of people collectively manage their assets. This could be a voting mechanism, it could be some other mechanism, it could be a mechanism that has kind of different modifications to it, but this is something that a lot of people are starting to kind of get interested in, right? So the idea of DAOs has this kind of 5-year history. It's a concept that a lot of people have been excited about. People tried building them about 3 years ago. At the time, the technology to actually build these things safely was not very mature, and so things like the DAO hack happens that people may have heard of. But more recently, there is this kind of second-generation DAO renaissance, and the technology is much more mature now than it was even 3 years ago, and people are looking to build DAOs for more and more use cases. So there's one that's doing kind of grants for Ethereum open source software development, and there's others that are starting to be designed like to run Ethereum-based applications for kind of nonprofit purposes for many kinds of things. So this is like one example of something that people are trying to do on top of the Ethereum platform. But the story is even larger than this, right? So let's talk about rules. Now, in our society, like, we have many kinds of informal institutions, and we also have many kinds of formal institutions, right? So money is an example of this. Corporations are another example of this. Corporations have boards, corporations have directors, they have rules for like what set of people need to do things for that to count as the corporation doing something. Political systems have rules. Social media systems have rules. So a lot of these institutions can be expressed as some set of rules that define how individual actions, the actions of individual participants inside the system, can affect some common shared state. So money, for example, you can think of money as a database. And the rules of the database are, if that database has a number beside your name, and say that number is 50, then you at any time have the ability to take subtract any number you want from your database, from your value in the database. So you can take that 50, replace it with any smaller number. Can't be negative, and it can't be bigger than 50. It can't be smaller than 50. And then whatever the difference is, you can use it to increase someone else's balance. Right, so you can think of money as this kind of database that has one simple rule for how people have the ability to kind of adjust the contents of the database, to adjust the state. And this is a social institution. It is a rule, and it's a rule that helps to facilitate a huge number of interactions in a global society. Now, money is not the only thing that is an institution with rules. Boards and corporations are one big example. Political systems are one example. Voting on social media is one example. So here the rule is that if you have an account, then you can like a post and you can kind of increase its score by 1. On Reddit, you can upvote or downvote. You can increase or decrease the score of a post by 1. So there's some notion of a kind of state of the system, which is like what things people said and what their scores are, and there's these rules for how things can be updated. So much of our ability to organize in large groups, much of our ability to sustain collaborations of basically more than what's called Dunbar's number, about 150 people, is based on mechanisms of this type. Now, what blockchains can do is they can create rules for kind of rapid experimentation of these kinds of mechanisms, right? And these mechanisms could be used for many things. They can be used to reward contributions to public goods, so reward contributions to projects that very many people find valuable, but where there's no single person that finds them valuable enough that the single person is willing to pay for them. So stopping climate change would be one example of a public good. Deciding how to allocate limited resources, encouraging economic activity between participants, like things like local currencies, and govern the use of different resources. So a domain name system, for example, you would want a mechanism to run to figure out who has the right to use some domain name for at what time. So there's a lot of areas where designing new kinds of formal mechanisms can be very helpful. Now, let's look at ENS. So ENS, decentralized domain name system, it's a decentralized alternative to basically this kind of existing phone book that we have that determines which website corresponds to which computer on the internet. And Ethereum is a decentralized version of this, is a fairly complex kind of set of smart contracts, set of programs running on the Ethereum blockchain that's used for registering domains, transferring domains, handling when domains expire, running auctions for domains, so a lot of different operations. And it even includes a kind of very simple kind of proto-DAO, a very simple kind of decentralized organization out of 7 participants for managing upgrades to the whole system. So ENS is an institution. It contains this fairly complicated set of rules, and they're encoded in this kind of program. Moloch DAO. This is a DAO in the Ethereum ecosystem that's there for kind of funding public good projects, for funding projects that are kind of benefit the entire Ethereum blockchain's ecosystem. And Moloch DAO has this kind of unique mechanism that it actually learned from some of the failures of the original DAO 3 years ago. And the mechanism is called a rage quit. And the way that this works is that if you're a participant in the DAO and you do not like the direction the DAO is going, so you disagree with the majority, then you have the ability to basically immediately exit with your share of the remaining funds. So it's a pretty simple mechanism, but it can be very powerful in basically preventing majority takeovers. Harbinger taxes. So this is one of these kind of new buzzwords in economics. The idea here is that it's a form of a kind of partial property ownership. And the idea behind Harbinger taxes is basically that the current owner of some asset has to publish a price, and whatever price they publish, they have to kind of automatically be willing to sell the asset at that price. So if you implement this on a blockchain, you would have to publish a price to a smart contract, and anyone would have the ability to send a transaction which pays that amount of money and buys the thing for you. Now, you might ask, well, why not set your price to infinity? And the answer is basically that you have to pay a tax, so maybe 1 to 5% per year, on whatever the value of the asset is that you set. So Glenn Weil wrote this wonderful book, Radical Markets, that has an entire chapter kind of talking about why this kind of partial property ownership mechanism could be interesting in a lot of cases, and even it manages to do two things that are often kind of in conflict with each other, right? One is to kind of raise ongoing revenue, and the other is to kind of actually mitigates monopoly power. Basically, in the case where you have someone, or there's a risk that some asset gets captured by one actor that's not willing to sell it except at an extremely high price, this mitigates the possibility that they will do that. So one of the Ethereum community developers, I believe this is Simon de la Riviere, has published this smart contract where to illustrate how this mechanism works, he created this artwork. So basically, it's just a token on the Ethereum blockchain representing this kind of digital piece of art. And this token is inside of a smart contract that basically implements a Harbinger tax system, right? So it implements a system where if you are the one holding that token at that particular time, then you have to basically put in deposits and you have to pay a tax equal to 5% of whatever price you set. And whatever price you set, anyone else has the ability to buy it from the current owner at that price, and then they would have to start paying the tax. So right now, you can go and buy the thing for about $45,000, but it's meant as a demonstration, right? So Harbinger taxes can be used potentially to improve efficiency for things like domain names, for many kinds of indivisible property, in a lot of different cases. And blockchains are this really nice and useful playground for implementing these kinds of things. Badges. So a badge is a kind of on-chain, non-transferable token that certifies that you did something. Right, so you could get a badge if you attend a conference, you could get a badge if you donate to charity, you could get a badge if you contribute to open source software. And these badges would be kind of done through this open blockchain-based standard, and applications, and including third-party applications, can show these badges. So this is kind of one live example of this. So there's a kind of blockchain-based decentralized Twitter alternative called Peepeth, and what it does is one interesting feature that it has is this badge system. And over here, this is a kind of badge that you can get where if you donate at least $25 to the Against Malaria Foundation, then you automatically get this badge, and it shows this. Right? So basically, blockchains can be used to kind of experiment with these kinds of designs for giving basically social rewards for kind of doing warm, fuzzy good things. Community savings, insurance, so rotating savings and credit associations, in general, kind of clubs of people where they pool money together, and then there's some rules that when they can take the money out. This could be used for insurance, this could be used for savings, it could be used for many things, and there's projects that are creating things called trusted lending circles that basically implement these kinds of designs on blockchains. Account management is another one. So basically, the idea here is that you can create a kind of computer program on a blockchain that kind of protects your own account against the possibility that you lose your key, against the possibility that your key gets stolen, against the possibility that your computer gets hacked, or any of these kind of individual events. And you could have some fairly complex rules for how this happens. So for example, you could have a rule that says you set like 7 different contacts, and any 4 or any 5 of these contacts together can kind of recover the access to some account if you lose access to an account. So this can be used to prevent cryptocurrency losses, potentially to prevent cryptocurrency theft, and even kind of replace like centralized account security, even for like signing into regular websites. So blockchains make it much easier to build all of these things, right? So why are blockchains so interesting? Because first of all, they have first-class support for cryptography. So they have first-class support for what's called kind of a user-sovereign model for basically like authorizing messages and like storing and attesting to information. Users have keys, cryptography is used to sign messages, and so everything is kind of directly authorized by users. First-class support for digital assets. Blockchains contain cryptocurrencies, and you can issue your own assets. And more generally, this like very unique primitive of global shared state, kind of a global shared memory that everyone in the world can see and everyone in the world agrees on. With blockchains, you can avoid dependencies on centralized parties, and they're a global open platform where anyone can participate. So there's a lot of different people like using blockchains to build different things, and I mean, if anyone here is inclined to be a developer, is a developer already, like I highly encourage people to check it out. And I mean, if you're not, then there's plenty of other ways to participate in these kinds of projects as well. And like many different kinds of projects like this are happening. So I encourage people to look around more and check them out. Thank you. Thank you.
So did we get any questions on the Slido website? Okay, there are some questions coming up. Okay, according to the recent IFRS announcement, virtual currency was defined as an asset, not currency. What do you think about this decision?
I think that like defining virtual currency as not being a currency, in the short term, it can even be a good thing, right? Because, like, in most places, like, first, if it's not defined as a currency, that doesn't mean that you can't use it for trade. Like, in general, kind of barter trade, like directly trading a computer for a chicken, or like any two things together, is totally legal and accepted as something that happens. So, like, I don't even think that it would prevent kind of like most of the cryptocurrency use cases. And kind of not putting it into specific categories it may even be good because it simplifies things from a regulation perspective. I mean, in the long term, I think like there are definitely reasons to kind of come up with some category and kind of normalize like explicitly kind of virtual currencies more. And I think like one of them is to just make sure that there's a kind of tax structure that doesn't make it extremely difficult to use them legally. Like from a capital gains perspective, I know that's a problem in many places, but not in all places. Like many countries in Europe have kind of passed laws to make that easier. So I guess like in the short term, and I don't think that a classification of like cryptocurrency as being like a non-currency asset is even a bad thing.
Okay, well, but in a way, for the cryptocurrency or blockchain technology to be really implemented in the world, for example, if the smart contract to have actual legal implications, or the, for example, like Oracle to earn public's trust, there has to be some sort of the public trust through the blockchain and through maybe policies. So do you have any idea like maybe how long it would take or how much it should take to?
So, and I definitely agree that blockchains cannot do that much by themselves, and that kind of more integration with the real world is really needed. But I think that a lot of the integration is something that can happen kind of mostly using existing structures. So for example, if you want an oracle that provides data and you want people to trust it more, then there are ways to kind of provide legal agreements and create legal structures where whoever runs the oracle kind of is required to publish correct data. Another example of blockchains having legal effect is if you look at stablecoins. So USDC, GUSD, all of these kind of fiat-backed tokens on the blockchain. In many cases, what they already are is tokens where if you hold some number of units of the token, you have the right to convert those tokens into the underlying asset. And so transactions on the blockchain that transfer the token actually do transfer that underlying legal right. So for currencies that exists, for corporations, it would be definitely interesting to see kind of more implementation of corporate structures where you can do kind of corporate governance operations on the blockchain. I know that's been tried a couple of times. I mean, I know privacy was one barrier a couple of years ago.
Sure.
But it's if it can happen, then I think it would both be much better than the current system, which is often based on paper half the time, and also would enable interoperability with a lot of other applications.
So I know you've been involved in the blockchain community since 2011, and there's a question saying Bitcoin in Korea is getting recognized as not a mainstream anymore. So many people are reluctant to invest money. What's your thought on this and future?
So, I think first of all that these technologies and these assets are fairly new, and so I think people are right to be careful, and we definitely should not be telling people that it's okay to not be careful. But I think that over time, as the technology continues to prove itself, then people's fears will kind of continue to reduce, and over time it will become a more and more accepted and mainstream part of society, the same way that the internet was.
And I think the third one is about 2.0.
Proof of work to proof of
Yeah.
stake. Yeah, so and I can talk about our progress to proof of stake.
Yeah.
So in general, right, in Ethereum, we have this kind of multi-year effort where we've been working on what we call Ethereum 2.0, this large set of upgrades to the Ethereum platform. And Ethereum 2.0 will be split up into kind of 3 stages. The first is phase 0, which we plan to launch early next year, which will contain an implementation of proof of stake, and the version of proof of stake consensus called Casper FFG that we have been working on for a long time now. And phase 0 is very kind of close to completion, and we had this big workshop at the beginning of September where we basically got all of the different kind of implementations of the Ethereum 2.0 protocol to talk to each other, and this is a very large step toward being able to kind of make and run a full public network securely. So that's phase 0. So, which has proof of stake. Phases 1 and 2 kind of implements sharding, which is our scalability solution, in 2 stages. And after sharding, the capacity of the blockchain will increase, hopefully by a factor of about 1,000. And then after phase 2, there's phase 3, which just implements a set of different optimizations. And we haven't fully decided even the contents of phase 3. I mean, we know one of them. It's an upgrade to the consensus algorithm called Casper CBC, but we're not sure of all of the others. So after phase 2, after phase 1, the blockchain will already be usable for many things. After phase 2, it will be fully usable for basically everything that you use Ethereum for now, except it will be much more scalable, much easier to validate, and much easier to use.
So you're also founder of Ethereum, so it's kind of like running a big startup, I would think. There must have been some actions that yourself or the Ethereum Foundation has taken to expect one thing, but then leading different results. So could you give us an example of those what Ethereum did and turned out to be a disaster, or sometimes happened to be a good thing for your community?
And I think the whole kind of DAO situation was one big thing where things then did not go as expected. So what happened there is basically that people created this thing called the DAO, which is this kind of the first DAO, and it's a kind of decentralized investment fund. And it turned out to be much bigger than they expected. So when they did the kind of open funding for it, they expected to get maybe a few $1,000,000, but they actually got over $100 million.
Wow.
And then it got hacked, right, because the code was just written incorrectly. And so as a result of this, we've started really caring about code security and responsibility and kind of releasing things carefully much more. And there's kind of a lot of lessons that were learned from that incident, a lot of programming languages that were improved. And like for maybe 1 to 2 years, people were were even kind of too scared to like write new smart contracts that would contain kind of large amounts of money. I mean, now of course, smart contracts are becoming more popular again. Things like MakerDAO have proven themselves for more than 1 year. Things like multi-sig wallets, like a multi-sig wallet broke about 2 years ago, but now there's multi-sig wallets that have been formally verified, like automatically checked, and mathematically proven to be secure. And so people are willing to kind of use those technologies more. I guess in general, like the thing that like the amount of time that it takes for technologies to be used maturely without breaking is something that I think definitely. I mean, it surprises lots of people. There's entire psychology books about this, but it definitely surprised us too. I mean, ICOs I think were definitely surprising.
In a good way or bad way? In a good way or bad way?
Both. I mean, like ICOs are interesting because on the one hand, right, like there's this big problem in the economy that a lot of things are like, especially public goods, are very difficult to fund, and like it's very difficult to find business models and often business models involve kind of completely breaking your product. Like there's a lot of controversy, for example, about how making business models based on advertising gives people the incentive to create products that are bad for consumers. And ICOs allow people to create this new business model where you can issue tokens, and like the incentive seems to be to create a project that's like good for users. So that was the hope, and like you cannot discount them completely because like even Ethereum itself was created by a token sale. But then the problem is, of course, that like this is why like regulators have gone after them so heavily in many countries, is because the incentive structure is just so horribly misaligned, right? Basically, like normal projects are you work hard, and you get paid. Here, the structure is you get paid more, and you decide whether or not you want to work. And like this is like really not healthy, right? So of course now we're looking into kind of different kinds of fundraising designs that avoid like those kinds of issues, and like we've been looking at, and I mentioned things like DAICOs, like public interest projects, like a lot of designs that do kind of follow this kind of good, more honest, like you work and you get paid format.
Right.
But it's still. And like this actually kind of ties back into like the thing that I was talking about, kind of blockchains for institution design, that you actually can like more easily experiment with these structures where you can create these like systems without requiring trust. Like ICOs are a contradiction because they like the blockchain space is all about minimizing trust, but the ICO concept is all about like, hey, let's trust a completely unknown group of people with $100 million. And so I think people are realizing that like there are many very wrong things about this. Yeah, so I think like the way that bubble kind of came and went is definitely something that we did not expect, and there's definitely things that like I think we as an ecosystem have learned from it.
Okay. I think you get this question a lot, but since this is an open session for the public, I'm gonna have to ask: if my 5-year-old nephew asks me what Ethereum or blockchain is, How would I explain?
I mean, if it's a 5-year-old, then like, look, it's like digital coins. I mean, if you go up to kind of smart 10-year-olds, then like, and you can think of it as a kind of virtual computer in the sky, where like, if you wants to build an application, then you can kind of write a piece of code, publish it, and it just runs, and it just runs in the way that you expect it to just run. And like, you don't have to think in the same way about like, who's running it, can I trust the person who's running it, and all of these things. So if you want to kind of build something that lots of people will use, and you want to be really sure that it will continue to work and it won't break, then a blockchain is like a really good place to build something like that.
I think the first and third question could go together. Do you believe cryptography skill is strong enough to be hacked and not to be hacked? And Google has recently announced their breakthrough in quantum computing. Would Ethereum be resistant to this latest technology?
So with cryptography, I think cryptography as a science is mostly fine. The thing that's less fine is actually like, basically, like, we have like good end-to-end security, like if we want it. The thing that we don't have is security at the end, right? Like if like you and I have a chat conversation and it's end-to-end encrypted, then like pretty much all of the time, if the contents of that chat conversation like get discovered, I mean, unless it's one of us that leaked it, then it gets discovered because one of our 2 devices was compromised. And the security that we have kind of at the end is still like really not good. And like, hardware is all proprietary. It's difficult to trust the hardware. You don't know like what the back doors are. A lot of software is proprietary. Operating systems often like don't have very good security settings, and so on and so on. I think security at the edges and what security experts call kind of the problem between the keyboard and the chair, and the problem behind the keyboard is like, those are things that I think kind of we need to do more on. For quantum computing, I think quantum computing is one of those things where there is like a huge amount of misinformation about it. So like, for example, like this quantum supremacy thing, right? Like, all that it proves is basically that like, in some sense, that quantum computing exists, right? It just proves that there exists one computation that quantum computers can do that kind of classical computers cannot, at least they think cannot easily replicate. And that's very different from saying that quantum computers can do specific computations that we want them to do. The kind of quantum computation that they did is like basically equivalent to saying like, imagine you have like, you take 1,000 like metal sticks, put them together on a haystack, and then you throw a grenade inside, and the grenade blows up. Like, the 1,000 metal sticks will go to different places. And so you might think like, okay, look, we proved that it is possible to distribute 1,000 sticks. And like, you can, but like, we still have, it's not that useful because you can't really control how you're distributing them. So like, quantum computers do have algorithms that can break some cryptography, not all cryptography. So they cannot break hashes, they cannot break lattices, they cannot break like many things. And so we do already know how to make cryptography like, for every cryptographic use case that resists quantum computers. But for that to happen, like, you still need many things. You still need quantum error correction, you still need thousands of qubits, you still need many other things. And so we're definitely still like some time away before quantum computers become a real and pressing problem for cryptography. But like, after they do, then I mean, basically we already know how to upgrade.
Are there more questions after these, or is there any question that you would like to answer?
I mean, I can definitely talk about kind of interconnecting Ethereum with other blockchains. I definitely think that it's valuable, and there have been some experiments in already doing this. So for example, there have been multiple experiments, like one of them is called Sumo, one of them is called BTC Relay, that kind of can allow smart contracts in Ethereum to verify transactions on the Bitcoin chain. And this can be used to do like trust-free exchange between the Ethereum and Bitcoin side. So I think things like that are definitely valuable. And in the future, if we have applications on many blockchains, then kind of blockchain interconnectivity can really help us achieve that.
Sure.
Yeah.
But as a platform, as a platform, you would want all these other services or other players to come into Ethereum and play, to have your more dominance. So what is your thought on that?
And I don't think that we're going to get the entire world on one platform. And I think, like, to the extent that there are going to be things on other platforms, it's good to be a good neighbor and connect out to them.
Sure. All right. Well, I think we're going to finish the session a little bit early. And thank you very much for joining us today. Thank you.
Thank you.